Hi. So now we are going to talk about superposition principle. What is superposition principle? And also we will discuss about the electric field, the combined electric field also. Okay. So this is actually a Coulomb's law portion, and we will discuss this one with electric field, both of them together. Okay. So what is superposition principle? Have you heard superposition principle before? Yes, you must have heard about the word. Where? In waves. In waves, we have seen the superposition principle. So similarly, like in all the case of vectors, we will have one superposition principle. Here also we have superposition principle. So I would like to explain what is superposition principle first. Then we can look at the mathematical portion of this. Okay. So look at this. So where here Q1, Q2, Q3, a system of charges are there. We want to find out, suppose if we want to find out the force acting on one single charge, that is equal to the force acting on 1 is equal to, that will be equal to the vector sum of the force acting on all other charges. That is Q1, the force acting on F1 is equal to F1 net. What is the meaning of net? Total. Okay, the vector sum F1 net is equal to F12 plus F13 plus F14 plus F15 plus etc. till n, F1n. Okay, this much will be the total force. That is what a superposition principle says. So what is superposition principle? The vector sum of all the net force acting on one charge will be equal to the vector sum of all the forces acting on that. Okay, so we can write it again. F1 net is equal to, it will be 1 by 4 pi epsilon 0. Let's say 1 by 4 pi epsilon 0 we can take outside, because in every force 1 by 4 pi epsilon 0 will be there. So we can take outside. It will be, what about this one? Q1 Q2 divided by, what about this? It will be Q1 Q2. Q1 Q2 divided by R21 the whole square into R21 cap plus the direction matters, right? Again, Q1 Q3 divided by R31 modulus square into R31 cap plus, what about this? F4 Q1 Q4 divided by R41 the modulus square into R41 cap plus etc. So this is what is the superposition principle, etc. Okay. So till n, if there are n charges, till n. Okay, no problem at all. So this is what is known as superposition principle. Okay, and next we are going to talk about what about electric field. What about electric field? Suppose there are n number of electric fields. E1, E2, E3, etc. n number of electric fields are there in a region. Then there is also, we can write E net is equal to, at any point. Let's say this is point P. At point P, which is equal to E1 plus E2 plus E3 plus etc. till En. Okay, this is what is the, you can say that the superposition principle of electric field. Electric field, the total electric field will be the vector sum of all the electric fields. So this is what is our equation. I think you have got it. Okay, you can write it as EP net is equal to 1 upon 4 pi epsilon 0 into here Q1 by R1 square, Q1 by R1 square, it will be R1 cap plus Q2 by R2 square, it will be R2 cap plus etc. Okay, so this is what is the electric field. So this is superposition principle, and here it is the electric field, the combined electric field or net electric field. Sorry, it's not corona. Okay, So this is what is the total electric field. Okay, thank you. So hi everyone. In the previous video we have discussed superposition principle and electric field due to the combined electric field or the net electric field at a single point. Okay. Now we are going to solve one problem. Example number page number 850. Example number 1.7. Okay. I'll read the question first, then we'll solve the question. And the question is: consider the charge configuration as shown in figure. That is, a Q1 charge is there and Q2 charge is there. Okay. And then calculate the electric field at point A. The 2 millimeter, the distance is given. This is the point origin. 2 millimeter here, 2 millimeter here. And we have to find out the electric field at point A. Okay. And also one more question is there. If an electron is placed at point A, so if an electron is placed at this point A, then what is the acceleration experienced by the electron? And the mass of the electron it is given 9.1 into 10 to the power minus 31 kilogram, and charge of the electron is also given minus 1.6 into 10 to the power minus 90 coulomb. Okay, now we are going to solve this question. First of all, if you can solve this problem, you can pause the video and you can solve it yourself, and then just come back to the video or the remaining portion. But I am going to solve this question. All of you listen. Here we have to consider the direction. We have to consider here two electric fields are there. We have to combine them, or we have to find out the net electric field. And I would like to teach you some more tips as well here. So listen, all of you listen. Here, look at this. First of all, one thing you have to be very sure. Q1 is equal to 1 plus 1 microcoulomb. Q2 is equal to plus 1 microcoulomb. And O, suppose I would like to call it as B, and here it is C. Okay. OB is equal to 2 millimeter, and AC, I mean this distance, AC is also equal to 2 millimeter. Okay, this is 2 millimeter and this is also 2 millimeter. And I can say that this electric field, the magnitude of electric field due to this charge will be equal to the magnitude of electric field due to this charge. Why? Because charges are equal and the distances are also equal. So R vectors are also equal, but the directions are not equal, but the magnitude, both of the magnitudes are equal. Okay, so now we are going to solve first portion, that is, what is the electric field? Electric field due to this one, I would call it as E1. E1 is electric field due to this one. That is equal to 1 by 4 pi epsilon naught into Q1, that is Q1 divided by R square, R1 square into R1 cap. Okay, this is what is the value. And how much will be the numerical value? 9 into 10 to the power 9 into Q1, 1 microcoulomb, 10 to the power minus 6 divided by 2 millimeter square. So 2 square 4, millimeter square 10 to the power minus 3, the whole square 10 to the power minus 6. So here 10 to the power minus 6, 10 to the power minus 6 got cancelled. It will be 2.25, again 2.25 into 10 to the power 9 Newton Coulomb resonance. This will be the value. And what is the direction of that electric field? I have already told you, the direction of electric field will be always from positive. It will be outward. It will be outward. So, and also, I would like to teach you one more small concept here. All of you listen. I would like to teach you one more small concept. That is, suppose if you want to find out the electric field at any point, suppose there is a region. You want to find out the electric field at that region. You have to do a small experiment, a small thing. What is that thing? You take a positive test charge. I have told you what is test charge. It's a small charge. It cannot make its own electric field, hypothetically. So look at this. They take that positive test charge and place at that point. Suppose if you want to find out the electric field at this point, take the positive test charge and put it here. Keep it here. So in which direction it is moving? That is the direction of electric field. For example, here I want to find out the direction of electric field here. So take this is my positive tester, I am going to keep it here. So it's a positive, it's positive. So it will move in this direction. Am I right? So now you got how to get the direction of electric field. Okay, so again once more. So what about E2? E2 will be equal to, that is also same value, same 2 millimeter. So the value will be 2.25 into 10 to the power 9 Newton per coulomb. Here also put the test charge here, it will go in this direction because it's positive. So this is what is my E1 and this is what is my E2. E1 and E2. Okay, so what will be the net electric field? Net electric field will be in this direction. We have studied in vectors. E net will be equal to in this direction. And look at this, equal. And what about the angle between them? This is equal to 90 degree. 90 degree. And if you do not know about this, I would like to teach you this. Please listen. The angle between two vectors are equal to 90 and the magnitudes are equal also. The magnitudes are equal. Then what is the net electric field? Net electric field, I would like to write it as E net is equal to, or all of you listen. This is what is this direction? Direction will be in this direction. Okay, is this I of j? This will be I. Okay, E2 will be I. Not this one. E2, this will be j and E2 will be I cap. Okay, this is j cap, this will be I cap. And what is the net? Net will be 2.25 into 10 to the power 9. Both are equal into I plus j Newton per coulomb. But we have shortcuts. Why do we follow this method? We have shortcuts. What is the shortcut? If two vectors are at an angle of 90 degree and then the net result will be in this direction and the direction will be, look at this, the value will be E net is equal to root 2 times of any of the value or root 2 times of one electric field, that is root 2 into 2.25 into 10 to the power 9 Newton per coulomb. This will be the value. This is the value of E net. Okay, net electric field. So you can vector, by using vector you can write this. This is the magnitude. What about the direction? Direction will be this one. How much will be that? 45 degree. No doubt in that. Because both are equal. Then the angle will be, then the value will be 45 degree. The angle 45 degree. And if you have confusion, no problem at all. Take this. How do you find out? E cap, E net cap, the directional vector. Directional vector will be equal to E net divided by modulus of E net. That is electric field, which is equal to, how much is E net? This one. Divided by that one. So it will be E net cap will be equal to I cap plus j cap divided by root 2. This will be the directional vector. So we have got the magnitude, we have got the direction, everything. By step you check, then only you will get it. Okay, otherwise you will get confused. And now the second part of the question asked is, if an electrode is placed here, how much will be the acceleration? So look at this. Here positive electric field is acting in this direction. If I place an electrode here, obviously it will move in the opposite direction. No doubt in that. Positive fields are in this direction, which means if I place an electrode here, it will move in the opposite direction. So the same way that the direction is very simple, it will move just opposite to the E net. E net value will go here, electron will come here. So that is no doubt in that. But the problem is how much will be the magnitude? It's very simple. You know that the net force acting on that electron, I would like to draw it here. This is the electron. The net force acting on it will be, the net force acting on it will be QE one force. QE will be one force acting on it and the same type, which is equal to mg. Why? Because look at this. Here, this electron, mg value will act in the downwards, but QE, this force is acting in this direction as well. So I can write Q is equal to mg. So what we want to find out? Or mg means m into acceleration a. So the acceleration will be equal to QE upon m. QE upon m. So here, what is Q? Charge of an electron. What is E? Electric field. And what about m? Mass of an electron. So mass it is given. Mass is equal to 9.1 into 10 to the power minus 31 kilogram. And charge of the electron QE is given, that is 1.6 into 10 to the power minus 90 coulomb. Substitute the value, you will get the answer. Okay, so all of you substitute yourself and get the answer and check with the answer, then you will get it. Okay, thank you. Hi. So now we are going to solve one last question from electric field, and then we will move on to the next topic. So before that, this is a good question. So it's a little bit logical. And look at this. The question is, I would like to read the question. And the question is very simple. It's age 2000 watt question. There are two charges are placed at a distance, at some distance. Okay. So one is Q and another one is minus 2Q. And the question is, the electric field at here, at this Q charge is E. It is given E. Okay. Then what will be the electric field at this point? At this charge? Minus 2. That is the question. Okay. So it is very easy to solve. So I would like to solve it. So the solution is, look at this. Here Q charge and the electric field acting, that is E. Okay. So according to our definition of electric field, we know that force acting on this charge will be equal to QE, or here capital Q. So capital Q into E. Am I right? So the force, the net force acting on this will be equal to capital Q into E. That we have already seen. That is F is equal to QE from the equation. Okay. So again, according to Coulomb's law, we know that the force acting on this charge will be equal to the same force acting on this charge. Am I right? Yes, because if they are equal and opposite forces, they are equal and opposite. They obey Newton's third law. So I can say that this F1 will be equal to the force acting on this. So it will be Q into E. That will be equal to the minus 2Q into E dash. What is E dash? The electric field acting on this. So that will be equal to, so we have to find out E dash. So E dash is equal to QE divided by minus 2Q. Q got cancelled, it will be minus E by 2. Okay, it's very simple question, but a little bit logical. Okay, thank you. So hi everyone. So now we are going to talk about electric field lines. Okay, so from the word itself, it is very clear that what are electric field lines? Electric field lines means like the field lines which we represent the electric field. So as we have already studied, what is electric field? So electric field is an abstract thing. Abstract means we cannot touch electric field. We cannot see electric field. What we can do only, we can identify electric field. We can identify the region where the electric field is present. Right? So to represent, to study about electric field, we need some imaginary hypothetical lines. Those are known as electric field lines.
there are some particular conditions, there are some particular rules which we have to obey to draw electric field lines. Okay, so those are the things I would like to discuss here. Those are the things I am going to discuss here. So there are many points in electric field lines. So in the board exam point of view and as well as in a conceptual view, like in a conceptual point of view, both it's very important. So you have to refer, you don't have to refer any other book, you just refer our textbook only. Okay, so we will discuss one by one what are the properties of electric field lines. First one, look at a positive charge. A positive charge can produce electric field line, or the electric field lines which is drawn from positive charge which are going away from the charge, going away. Look at this in that direction. So what about a negative charge? Negative charge, it will come towards the negative charge. Okay, or in another way I would like to say that, look at this, this is outward, these are outward electric field lines, these are outward field lines. And what about this? Inward, these are inward field lines. Okay, so that is first point you have to know. Second thing you have to know, look at this. Suppose there is a group of like positive and negative charge. Then positive charge, it will start from positive charge and it will end at negative charge. Electric field lines are starting from positive charge and ending at negative charge. You got it? So you will have a doubt. So where are these lines are going? These are not ending there. So we do not know where like they will end at this positive charge or sorry, negative charge or not. So we are not sure about whether these lines are started from positive charge or not. Suppose there is one charge alone. So look at this here, negative charge alone. It is, suppose we are not considering this positive charge. From where are these lines are coming from? These lines are coming from infinity. Okay, you can consider like that. Somewhere where the electric field is, positive electric field is present. Positive charge is present. Okay, so for our convenience, we will call it as infinity. What about this? These lines are going to infinity. Okay, you can consider like that. Suppose if there is a group of positive and negative charges, then it will start from positive and it will end at negative. And next thing, let's say another point is this is first one, second, third, and then fourth point is electric field lines never, electric field lines would not make a closed loop. For example, electric field lines, this is not an electric field line. Okay, so look at this, this is another electric field line, this is another electric field line. It is not like it's a closed loop. It will not make a closed loop. Another one, so this is not possible. Another one, the direction of electric field, that is another point. The direction of electric field, suppose at this point I want to find out the direction of electric field. It will be the tangent at that point. The direction of electric field at this point will be the tangent at that point. Okay, and that is my fifth point. So my sixth point, you have to read. Okay, so you can take your textbook, page number 28. You have to read 27, 28, and all. Okay, so sixth one, electric field lines, two field lines never intersect. Two electric field lines never intersect. Why? You think about it. We have learned this kind of thing many places, even in mathematics. So you know that suppose there are two electric field lines, they are intersecting at a point. So okay, they are intersecting at this point, which means it has two directions at this point. Here one direction, here one direction. So this is not possible. Okay, so electric field lines never intersect. At a single point, two directions, not possible. Okay, so next is 7. The intensity of electric field. You know that at some point the intensity or the strength of electric field will be much more, and at some point the strength of electric field will be lesser. What is the criteria? Look at this. I would like to take this as, okay, if the number of electric field lines at a particular region is more, which means the electric field at that region is high. Look at this. I would consider this region. Okay, how many electric field lines are there? 1, 2, 3, 4. I would like to consider a region like this. How many electric field lines are there? 1. So where is the electric field maximum? The intensity of electric field or the strength of electric field is maximum here. So electric field is proportional to number of field lines. Number of field lines. Okay. Then another one, say ninth one. Suppose there is a charge Q plus Q, and how would be the electric field lines? All of you think about it. Electric field lines would be inward or outward. Think about it. Inwards or outwards? Outwards. So it will be like this. So how many electric field lines are there? 1, 2, 3, 4, 5, 6. Okay, this is not accurate. So I am just talking like let it be like this. Okay, it's my assumption only. Then if it is like this, then what about a plus 2q? There is another charge plus 2q. Then the number of field lines will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, the strength of the electric field, it will always represent the strength of electric field. So here it is Q and here it is 2Q. So the strength depends on, like number of field lines is also depends on the strength of electric field which is produced by the charge. Okay, so these are the basics of, or these are the things about electric field lines. So you just go through the textbook and read it.